Rightio, question 7. We've got some integration here, and let's jump straight into it by the looks of it. Two expressions here to integrate. We've got limits 3k and k, so not numbers essentially, just some limits to put in. Show that the integral of 2 over 3x minus k, when you put in the limits 3k and k, is independent of k. So the k is going to disappear at some point by the sounds of it. So let's have a look. Let's start off by writing this down. Where are we? So part A, what are we doing? We're integrating 3k from k to 3k 2 over 3x minus k with respect to x. Now you could push the 2 outside if you wanted to. Push the 2 outside of the integral. Lots of people like to push constants out the front to make it slightly easier to see what you're integrating, I suppose. This looks like a standard result. Integrating 1 over something in this form when you've got 3x minus a constant is going to be something that we should kind of know the integral for, if you like. We should know the rule. So it's going to be, bear in mind I'm keeping the 2 out the front, so this will equal, let's put the 2 out the front of the result here. Alright, the integral of that is going to be 1/3, because we have a coefficient of x and we divide through by the coefficient of x in this result, and it's the natural log of what's in the bracket, so the denominator. Okay, so that's, sorry, I put a weird, that should be a modulus sign there. Put the limits back on, 3k and k. So we've got to run our limits through this and see what happens. I can put this together. The 2 times the third, if we wanted to drop these brackets, it's going to give me 2/3 ln. So let's use that instead. Alright, so the first thing we need to put through is we're going to do 2/3 ln, and then we stay there. 3 lots of our first value of x, which is 3k, minus k, close that off, minus k. That's our first limit in. Then we will subtract, don't we, the second one. So 2/3, put the second limit through the function that we've got here. And that is going to be 3 lots of x, which is just k this time, minus k. Okay, and that should give us some kind of result that we're looking for. So I can combine these logs. They're both the same logarithm, aren't they? And if you subtract, that is the same as dividing, isn't it? Dividing what's inside the modulus signs for the natural log. This is a log rule that I'm about to use here. So I'm going to kind of factor out the 2/3. And I'm going to put it over here, otherwise I don't have enough room to do the second part. So I'm going to get 2/3 of the natural log, and I can divide through the first one, which is 9k minus k, which is 8k, divided by the result of the second one. I'm simplifying this, so this is 3k, take away k, which is just 2k. That is going to go to 2/3 of ln of 4. There we go. K's did cancel out, so this is independent of k, alright? K does not appear in the result. So I'm just going to leave it like that as my answer. That's enough to show the point that it was making there. Second part, I'm probably going to need a bit more room for this one, so I'm just going to pause the video and adjust this slightly. You won't notice it, but right, second part, that was me just adjusting my PowerPoint there. Second part, we're going to look at something we're showing that the result of this is inversely proportional to K. So if you know, proportionality is, we did it at GCSE, an inverse proportion, we would say that Y is inversely proportional to X. So Y, has an inverse ratio with 1 over X. So Y would equal some constant K over X. This was what we used to talk about at GCSE. And that is kind of giving us a bit of a clue. Let's just have a look and see what happens. When we get the result of this, we'll see how that links to it being inversely proportional to K at the end. Alright, so we're just going to do this first, haven't we? Just going to work this through. So this is slightly different, isn't it? This is not in the same format as the last one, so I can't integrate it with the natural log standard rule. This has got a power on the bottom, so I'm going to have to actually get it into indice form and then integrate it like that. So the first thing I'll do is I'll write it out in a format that we can actually integrate it. So I'm going to bring it up and write it as a negative power. So that's the -2, okay? That's how I'm going to do this. I'm going to integrate it like this. And I'm going to use the chain rule, I think the reverse chain rule, because what is the integral of this? Well, let's start with something that could be the integral and differentiate it and see what we get. If I do that, try and do that in a box separately here, the integral of this is going to have a power higher. So if I start with that bracket, 2x minus k, start it at a power higher, because the result will have something to do with that power being 1 bigger. If I was to differentiate this, so let's call this y equals dy by dx is going to be times by the power, so -1. I'm using the chain rule here. Rewrite the bracket, 2 minus k, reduce the power by 1. So it's very close, isn't it, to what we started with. However, this is twice as big as this result here. Okay, so I'm going to have to adjust the constant to account for that. Actually, I've done something wrong, haven't I? You're supposed to multiply by the differential of the bracket. I nearly missed that there. What is the differential of 2x minus k? Well, 2x goes to 2 and k is a constant, so that would just be dropped. The differential of this bracket is just going to be 2. Brilliant. So that gives me pretty much what I want, apart from the fact it's going to have, if I put this out the front, the result is -1 times 2 is -2. Put those together. 2x minus k to the -2. That is exactly what I've got, apart from it's negative here, and I don't want it to be negative. So the integral, if I put a minus sign out the front of what I thought the integral would be, that is going to multiply by this negative sign here and cancel out. And I will get exactly what I want. So I know that the result of this, the integral of that, is going to be minus 2x minus k to the -1. Because when I differentiate this, I will get this back. So this must be the integral of it. Alright, and let's put the limits on 2k and k. Okay, too many k's, right. Let's put the limits through. So we're just literally going to write minus 2 lots of 2k minus k all to the power of 1 minus 1. I'm getting very sloppy at the moment. I've just been out for dinner and my brain is not functioning. Overeaten. So that should be -1 there. Sorry, this is looking a bit scruffy here. Right, let's carry on. I'm going to put a bar. Let's put it in minus. Again, minus. So that will become a plus in a minute. 2 lots of the second limit, which is just k this time, minus k to the minus 1. These two here, two negatives, are going to become a plus. So what do I actually end up with? I've got minus, what have we got here? Minus 4k minus, so that's 3k to the minus 1, which is 1 over 3k. Plus, this one is just, what have I got here? 2k, that's just going to be k to the minus 1, which is 1 over k. Add these together, well, we're going to have to multiply this by 3 to get a common denominator before I can add them together, and the result of that is going to be, I might do this one first because it's positive. So 3 over 3k minus 1 over 3k is going to be 2 over 3k. Alright, that's the result that I've got there. Is that inversely proportional to k? So it looks like it's going to be definitely, because you've got the k is on the bottom, so it's like it's something constant here over x. Over x is on the bottom, which our k is on the bottom. That should be enough to show the result that they're looking for. You've ended up with your variable on the bottom of the fraction. So yes, the result of this is, you can say that k is definitely proportional, isn't it, to, inversely proportional to 2/3 k. Alright, as k gets bigger, this is going to get smaller, inversely smaller by this scalar here of 2/3. Alright.